Hello viewers, I discuss today the few shortcut tips in topology regarding the short questions and MCQ based questions. And the viewer who are watching this video first time, they subscribe the channel and press the bell icon to get all the notification and latest update of my videos. At first, let's discuss if pi 1 from x cross y to x be defined as pi 1 of xy equals to x and pi 2 such that x cross y to y be defined as pi 2 xy is equal to y, then these maps pi 1 and pi 2 are called onto or surjective maps. 1 are injective or into map or none of these. Then how to solve this result? At first, if we look it into the matter, by definition we have for pi 1 from x cross y to x, by definition pi 1 of xy to x, and another definition, that's pi 2 from x cross y to y, and this by definition as pi 2 from x cross y to y. In these two mapping, it's clear that's nothing but it's y. From this two result, that's a projection map clearly, and if we find it results of our definitions analysis, and if given a two sets, if its result is x cross y, and if this result is another one for x, and this is clearly operating with for pi 1, and if we see that this pair of result that already projected as x1, if it will be as a pair of element if we take as x, and then if we are taking as a set of element x1 y, here it will be x1, and if it will be x2 y, so it will be x2, like this manner. An infinite number of elements we may choose, and this operation that's taken as pi will be the operator taken in this manner. And if we similarly find another component like this, so it's clear, and this projection operators that comes and already is given this result of this, so we find here this component corresponding to this component. So it's clear, images, the images has the pre-images, this component, and projection operator, so it's clearly onto mapping. So first option, that is a surjective or onto mapping, is correct. So the option number A or 1 will be correct. So number 1 option, that is these maps, number 1 is correct. It's very interesting results for the projection operator. It's not into, it's no possibility of into mapping and onto mapping also. So only possibility is there. We already know why this into mapping is not possible, because there is, if there is somehow this range set, if any element exceed than the domain set, then it will be an into mapping. Now let's watch another definitions and another problems. Now if we consider X be a Hausdorff space, and then any finite set in X is closed, that's the any finite set in X, that means Hausdorff spaces, and then we conclude that any finite set in X is closed, X must be empty set, its no set exists, like this set contains only 5 elements, and every finite set is open, and number 4th option is none of the above. Then how to cover it up? At first, if we consider this set like a singleton set, if we consider a set like this A, let set A, if we consider as an element X, and it is closed, and if any point Y is the other point of X, if we consider singleton, if we consider any point Y here x contain and any point y that's other than x, and that is x not equals to y. It is correctly problem. This x must not be equals to y if we consider other points. Then by Hausdorff property there is NBD of y which does not contain x. If we consider as NBD of y that doesn't contain x, it's not possible. It's not containing x, doesn't contain x, and which doesn't intersect at a, since it's not, so it doesn't intersect, so it is a closure of a closure point, and it's clear. And this closure of a that doesn't belongs to this y, since it's not belong to an any neighborhood exists, so this y point that doesn't belongs to closure of a, it's clear. And if this only exists, this closure of a, and it's not possible to any element of the singleton set a, so closure of a contains only one element, this is x, so x is closed and a is closed. So any finite union of the closed set is closed. It is a property of topological. So any finite union of closed set is also closed. So every finite set of x is closed because we are considering the union of any finite set. So first option, any finite set in x is closed. This is correct. This is not correct. This is not empty set. It is not possible, and it is not open. So only option is closed and first option is correct. Now we end our discussions today. Very valuable, important tips regarding this topology. If you like this video, like it, share it, and always subscribe the channel. Thank you.